Hello everyone, so welcome to the 3D geometry part 3. In this video I shall be discussing with the point of intersection of lines and the footer perpendicular images of the points with respect to the particular lines. So first of all I have a question where we need to find the point of intersection of the lines of two lines. This is the first line and this is the second line given in the Cartesian form. I shall be discussing a very important point regarding the whole mathematics here. Let me tell you that point, that whenever we have been given three or more things as equal, then you need to take that thing as some t, some s, or any other thing which you want. Like for example, here I've been given three things as equal, then assume those things to be some t. Okay, similarly, even if we have been given three things here as equal, now assume this thing also some like me say m. Okay, here I have assumed all three to be some t, here I have assumed all three to be some m. This is very useful in the case of the basic mathematics also, where we used to learn about logarithms, etc. Now let me take out the value of x, y and z from here. So x minus 1 upon 2 is equal to t. So from here I get the value of x to be 2 into t plus 1. Now similarly, let us find the value of y from here. How to find? Y minus 2 upon 3 is equal to some t. So y will be equal to 3t plus 2. 3 goes here and then plus 2. Now let us find the value of z from here. Z will be equal to 4t plus 2. So we have found out the value of the x, y and z from the first one. Now this can be written as in Cartesian form: 2t plus 1, 3t plus 2 and 4t plus 2. This is from line 1. This is the representation of x, y and z. That is the normal from the 3D geometry. Now let us do for the same thing for the second one. For the second one we'll get, see, x minus 2 upon 1 is equal to m. So x will be equal to m plus 2. Now from here y will be equal to minus 3 goes here. So minus 3m plus 2. So minus 3m plus 2. Minus 2 goes here. So z will be equal to minus 2m minus 1. So this we get from the line 2. So these are any of the points. See, we need to find the point of intersection. So first of all we must have a point. So this is the point here. This is any general point which can be manipulated on the line L1 by taking the value of t from anywhere like 0, 1, 2, anything which you want. Similarly for the line 2 we have this as the general point where m can be manipulated to get any value for as you want. Okay, now let us move on further. So if we need to find the point of intersection of the lines, then these two points must be equal. Why they must be equal? Because whenever two lines will intersect, the point of intersection will be the same for each of them. So let us assume this point. This is for the line 1 and this is for the line 2. So if these both are equal, it implies that the x coordinate has to be equal. So 2t plus 1 will be equal to m plus 2, which will give me the next equation as 2t minus m is equal to 1. So let me take this equation to be number 1. Let me make it in a rectangular box. Now similarly the y coordinate has to be equal. So 3t plus 2 will be equal to minus 3m plus 2. So from here the 2 and 2 gets cancelled. So we get t is equal to minus m. So this is the equation number 2. Now moving on to the third part where these two equations must be equal. Thus 4t plus 2 will be equal to minus 2m minus 1, which implies that we get 4t plus 2m is equal to minus 3. So this is the equation number 3. Now we have, you can see very carefully, we have two variables, that is t and m. And we have three equations, that is 1, 2 and 3. You can take any of these two equations to find out the value of t and m. So let us move on with the help of the first two equations. So we get t is equal to minus m. Put this value in the equation number 1, which will yield 2 minus 2m from here. Minus 2m minus m will be equal to 1. It implies that m is equal to minus 1 by 3. Now doing the same thing for the next one, we need to find the value of t from here. T is equal to minus m, so t will be equal to 1 by 3. Now we have got the value of m and t. Many students do this mistake here. The first time that I have done this question, I also did the same mistake. The mistake is that we have found out t and m from here. Now people put this value here to get the value of the point of intersection, but that is totally wrong. Now why is it wrong? Because if we get the values from the first two equations, then that value must also satisfy the third equation here. So let us put this value in the third equation. If these two values satisfy the third equation, then only these values are found out to be true. So 4 into t, see I'm using this equation, 4 into t, that is 4 into 1 by 3, plus 2 into m, that is minus 1 by 3, should be equal to minus 3. Now let us find out the value of this. So the value of this is 4 by 3 minus 2 by 3, that is equal to 2 by 3. 2 by 3 is not equal to minus 3. Thus the lines do not intersect. Why the lines do not intersect? Because we have found out the value of m and t by assuming that the lines intersect, but we don't find the values to be satisfied by the equation number 3. Thus the lines do not intersect in this case. Let me show you a very interesting case by two pens here. See, you can see two pens here. If you see from above the camera like this, you can see that the pens are intersecting. That is, the two lines are intersecting in some manner at a single point. But if you see carefully, see, if I do it like this, then you will see that there is some gap between the two pens. If you see from above, there is no gap between the two pens. But if you go on to the side, you see that there is gap between the two pens, which implies that these type of lines are known as skew lines. So these type of lines are known as skew lines. Now why these are known as skew lines? Because they seem to intersect at a particular point, but they do not intersect. Thus these are known as the skew lines. What I want you people to know is that, first of all, assume any point on the two lines. The 2 points must be equal in nature, that the value should be equal. Why? Because they are intersecting. Thus the point of intersection has to be the same for both the lines. But on finding the equations, we find that we get two values of m and t. Now if we put it in third equation, the value doesn't satisfy the third equation. Thus the lines do not intersect, and these are known as skew lines. Now moving on to my next question, which is regarding the image of the point 107 with respect to the line x by 1 is equal to y minus 1 by 2 is equal to z minus 2 by 3. So let us find the image. So for the entire maths, I've given you a tip here that whenever 3 or more things are said to be equal, assume that thing to be some t or m according to your favorite letter or whatever you want. So from here, let us find the value of x, y and z. So the value of x will be equal to t, that you can see very carefully. The value of y from here will be equal to 2t plus 1. The value of z from here will be equal to 3t plus 2. So this is the point on the line itself. Now we can vary the point on the line by varying the values of t. You can take t to be minus 1, t to be minus 2, t to be 0 according to your wish, according to which we can get the point on the line. So let me show you by a simple diagram that how to move on further for the question. So we have the line here. Let me say this is the point on the line. This is the point P, let me say. It is t, comma 2t plus 1, comma 3t plus 2. Okay, so this is the point on the line. This is the line. This line is shown here. Now we take this point here, 107, anywhere 107. Let me say this point to be Q. So what I want is that this is the line. You need to find the image of this point Q here. Let me say that image to be R, and let me say some x, y, z. So we need to find the point R, which is the image of the point Q with respect to this line here shown. So we can find out the direction ratios of this line. Let me say that this is perpendicular to this line. You can find any point P which will be perpendicular. The line PQ will be perpendicular to this line. Why? Because the T can be varied according to our wish. So this line is perpendicular. The PQ is perpendicular to this line, the green line here. Now the DRs of this line is what? See, if you remember from my previous video, the DRs of the line are same as the DRs of the parallel vector. So the DRs of the parallel vector are written in the below in the Cartesian form. So DRs are 1, 2 and 3. Now let us find the DRs for the vector PQ. So DRs for it will be equal to, see, t minus 1, t minus 1. Here it will be equal to 2t plus 1 minus 0, 2t plus 1 minus 0. Here it will be equal to 3t plus 2 minus 7. So that is 3t minus 5. So we have got the drs of this vector here, we have got the drs of this vector here. Now these two are perpendicular to each other. It implies that the dot product has to be equal to 0, because a dot b will be equal to 0 when theta is equal to 90 degree. So let us multiply these two. So t minus 1 into 1 plus 2t plus 1 into 2 plus 3t minus 5 into 3 will be equal to 0. Now simplifying it, we get t minus 1 plus 4t plus 2 plus 9t minus 15 is equal to 0. From here I get 14t is equal to 14 on simplifying the matter, and from here we get t is equal to 1. So I told you that we can vary the t according to our wish. The mathematically correct answer would be t is equal to 1 for these two lines to be perpendicular in nature. So let us find the point P from here. So point P will be equal to the value of t for 1. So 1, 3, 5. So we have got the point P, which is the foot of perpendicular. But the major mission is to find the image of the point with respect to this line. So that is point R. So we have got the point P, we know the point Q, we need to find the point R. Now we know that the point R and the point Q is there. The point P has to be midpoint of these 2 points. Why? Because we have studied in the physics chapter that the distance from here of the object from the mirror is equal to the distance of the image from the mirror. So that concept only I'm using here. The distance of the object from the mirror has to be equal to the distance of the image from the mirror. So this has to be the midpoint of the two. So it implies that x plus 1 upon 2 should be equal to the point T, that is 1 from P, and y plus 0 upon 2 should be equal to 2t plus 1, which is 3. And z plus 7 upon 2 has to be equal to 3t plus 2, which is 5. So from here I get x is equal to 1, we get y is equal to 6, we get z is equal to 3. So it implies that the image, that is the point R, will be equal to 1, 6 and 3, which will be the correct answer. A very important question for JEE Advanced, because it involves the concept of vectors, it involves the concept of the foot of perpendicular, it involves the concept of the image. So I hope that this video clears many doubts and teaches you new things. So if there are any doubts in the video, you can definitely ask me in the comment section, and best of luck to all of you.